Hello, today we will talk about threads in Python and how we can use them to our advantage. So first of all, we need to import two libraries. So the library time, and we need to also import threading. So now let's see how you can create a new thread. So you can define a new function called whatever you need, and you can just add a print statement inside. I guess foo method is called, and after that you can just say t1, that stands for thread 1, equals threading dot thread, and you can say target equals the name of our method. So to create a new thread, you need to call the thread function that's in the threading library, and you need to specify the target method in here inside of the arguments of the called method. But if we actually run this, you can see that nothing happens because we haven't actually started the thread, we have just created it. So now I can go ahead and actually say t1 dot start, and as you can see, it starts the thread and it prints foo method is called. So instead of let's say you could call this method by if name equals main, then you can call the function. So this would call the function itself inside of the main method. But what happens if instead of this we go ahead and do this? What happens is inside of main it creates a separate thread that runs the other function. So the way this happens is with two separate threads. The output for this example might be the same, but the threads here are two. We have the main thread and a new thread that we just created for this function to run. So you might be wondering, if the output is the same, what's the benefit of doing all of this work, importing these libraries, creating new threads, if the final output is still the same? So to answer this, we can give another example. So let's define foo1, so we can print foo1 method is called, and then let's just do time.sleep for 10 seconds. So this will just make the program wait for 10 seconds before continuing. And then we can just print another statement, foo1 method has ended. Okay, now let's define another function. Okay, now let's just copy this code here and paste it here. Instead of 10 we can do 5, and let's replace foo1 with foo2. Okay, now let's try to call them. Okay, so like we did before, if name equals main, then just call the functions one by one. Let's see what happens now. Okay, foo1 method is called. Now we have the 10-second delay. Okay, foo1 method has ended, and then the second has started, and now it has ended. So that took about 15 seconds in total. Okay, so now let's see what happens if we just create separate threads. So let's create a t1 which is equal to threading dot thread, and the target specified equals foo1. Okay, and now let's create a second thread. Let me just copy this, and we can call this foo2, and the thread we can call it t2. Now we can actually do t1.start and t2.start. Okay, so now let's run this and see what happens. Okay, so we can see that foo1 method is called and foo2 method is called. The foo2 method has ended and the foo1 method has ended. So what happened was we started both of them virtually at the same time, and the first one and the second one ended before even the first one had a chance to end. So that means that we can save a lot of time for when we need to execute many time-consuming processes. So this technique of creating threads and running them could save a lot of time, just because the program doesn't have to idle at all. We can just run something else instead of just wasting the time. And you also need to keep in mind this new term called temporal analysis, which is the process of counting the time it takes for multiple programs to execute. So for example, the foo1 function takes 10 seconds to execute and the foo2 function takes 5. So we can say that the foo2 function is faster based on its temporal analysis. And another term you can use is temporal complexity, which is also just the same thing. So actually let's implement this concept now. So in here, let's just revert back to calling these foo1 and foo2. And in the beginning we can define a start time, which will be equal to time.time, and this will just be the beginning time of our computer. And now we can also do end time equals time.time, and here is the time in the end of our programs. So now we can just print time consumed by program is, and then we can just use end time minus start time. So let's see what happens now. Okay, the program has finished, and just like we thought, it's been virtually 15 seconds. The rest of the time is just imperfections in the running time. Okay, so now let's do the same thing, but replace this with our threads. So again, we can do t1 equals threading.thread, and the target is the foo1 function. Let's copy this and do the same for the other function. And now let's just start the threads. t2.start. I will run this. Okay, so as you can see, we get the time consumed by program line before even these functions have ended. So that means that this is not the correct time it took, because it didn't even wait for them to finish. So the reason for this is because you can think of the main method of this here code as the main thread that is running alongside t1 and t2. Okay, so this code will be executed line by line without waiting 10 or 5 seconds here. Okay, so the way we can fix this is by using the method join. So t1.join and t2.join. So what happens now is the main thread will wait for these two threads to finish before continuing. So if we run this again, we can see time consumed by program is 10 seconds. So 5 seconds for foo2 and 10 seconds for foo1, but these run in parallel, so just the biggest one counts. So foo1, when that is finished, we can tell that the end time is here, so the total time consumed by the program will be 10 seconds. So one more thing that you need to know before moving to the exercise is that okay, so what happens if we needed to specify parameters here? So let's say we had here a name for some reason. The way we could specify parameters when we run this as a thread would be if we just did comma args equal, and then we could just specify the name here. Like we could use a string called I don't know, foo. Okay, so this is how you, and if there were more parameters, you could just comma second param and so on. Okay, so this is how you specify the arguments when you want to run when you want to start a new thread. Okay, so let's take a look at the exercise you have to do. First of all, this piece of code is given here, and what you have to do is you have to implement the main code to call these methods using the regular approach, so just calling them regularly, and you have to calculate the execution time for both methods using the regular approach, and just repeat the same thing, but just do it by creating separate threads and measure the time it takes to do this. Okay, so I fixed the last line. That's it for the exercise. Try to practice and try to complete this. You can use all the knowledge you gained in this lesson, and that's it. Always remember to practice.